Good morning, sir. My name is Sayam Bhaskar. My roll number is 33. So, my topic is about pushing and pulling in microwaves bytes. So, I am from EC department. My course is about analog electronics. My core is AEC D0 D09. So coming to the topic pushing and pulling in microwaves bytes. So coming to introduction, in our increasingly interconnected world, the efficient flow of data is paramount. Whether we are streaming high definition video or receiving real time stock updates or downloading large files, the way data is transferred significantly impacts our experience. Today we will delve into two fundamental models of data transfer, pushing and pulling. Significantly, we will examine how these models operate within the realm of microwave bytes, the digital information transmitted via microwave technology. Understanding this concept is crucial for anyone in or interested in modern communication systems, especially as microwave technology continues to play a virtual role in bridging connectivity gaps and enabling high speed data transfer. And coming to what is pushing, first of all, pushing is a data transmission method where the sender uh, sends data to receive without a waiting for a request. This approach is useful in scenarios that requires real-time updates. Example for push mechanisms: live streaming, video or audio connect in continuously push to users, IoT devices. Smart sensors sends real-time data to a cloud server notifications. Websites send push notifications to the users. Advantages of pushing: first advantage is real time updates, second one is reduces client side processing, and third one is efficient for continuous data flow. So disadvantages for pushing is requires continuously connectivity and can overload networks if not managed properly. So these are the advantages and disadvantages of pushing. And coming to what is pulling. Pulling is a data transmission method where the receiver requests data from the sender which when needed. This method is useful when the data updates are not frequent. Example for pull mechanisms: web browsing. A browser sends a web page. A browser requests a web page when a user enters a URL. API request. Applications fetch data from server as needed. File downloads. User manually download files from cloud storage. So advantages for pooling: saves bandwidth as data is requested only when needed, gives users control over data retrieval, and reduces unnecessary data transmission. So these are the advantages of pooling. And disadvantages of pooling: may cause delay in receiving updates, requires frequent requests for a real-time data. So these are the advantages and disadvantages of pooling. And the key differences between push and pull: first one is feature for pushing and pulling. Data flow is continuous in pushing, and data flow in pulling is on demand. And bandwidth usages in pushing is high, pulling is more efficient. Use case: live streaming, IoT in pushing, and web browsing and API calls in pulling. Latency is low in pushing and can have delays in pulling. And coming to next slide, how pushing works in microwaves networks. Microwaves communication transmit high frequency radio waves for wireless data transfer. In a push based microwave systems, data is continuously transmitted from source to the receiver without waiting for a request. Example: satellite communication. Satellite TV broadcast push data to receives without user request. Next one is how pooling works in microwave networks. In a pool based on microwave system, the receiver requests data from the source before transmission occurs. For example, on demand video streaming. A user selects a video and servers pull the data to send only the requested content. And considerations. Push mechanisms to spam and unauthorized data transmission. For pull mechanisms, more secure but requires sanitization to prevent unauthorized access. So we are concerned with a RF push pull amplifier, which is a derivative rather than a direct descent of the basic classical audio configuration. There is an important difference in making the leap from a audio hertz to frequency hertz to RF megahertz. In an RF application, the signal is sinusoidal. As such, the basic action of the differential arrangement to preserve the complex broadband audio waveform is no longer needed. In need a gigahertz frequencies, we can and do much as to certain PIA and many others use single-ended amplifiers based on it on year 2. The class B condition on the basis that the resulting rectified sine wave can be converted back to the original sine wave using a suitable filter, and there is a clutch of the whole matter. This suitable filter ends up having a number of requirements that depending on the application and in a particular that required single bandwidth can be conflicted. Push pull in principle can take on a different solve in resolving the conflict. So this is a figure a basic push and pull amplifiers schematic from figure 2, which I reproduce with some mixed feelings, shows us the curve rent and voltage waveforms of class B RF amplifier. The current through the auction of the transistor based on setting is half wave rectifier uh, cosine wave, thus easy bit. But time and again in books, papers, and blackboards throughout the ages, the voltage is shown as zero grazing cosine wave. I hesitate to disclose my age when I was first puzzled by this. I probably first encountered it in some ham radio handbook from the 1950s. The heavily distorted current wave from the ridge in harmonics, and the voltage can be of almost anything depending on the properties of the output load. Ideally, we would very much like the voltage to the sine wave I've shown. This set of waveforms, if released by whatever means, will delivers maximum power from the device at an efficient of just over 78%. But no, to achieve this, the fundamental load has to prevent a specific resistive value at the fundamental frequency and a short circuit at the harmonic frequencies. So this is a figure 2 about class B waveforms, voltage and normalized to VDC and current normalized to peak value. So this is a waveform. For low and even moderate bandwidths, which simple circuit configurations can deliver an acceptable Elsbit approximate solution to these requirements. But there is clearly a conflict if the bandwidth extends beyond an octave. You can't have a network that provides a short circuit at the upper end of the current band while simultaneously provides a resistive load when the signal moves to the same upper frequency. In practice, when the active device is a transistor, the likelihood of achieving the perfection of figure 2 is more or less all to acceptable power and efficiency are the routines obtained in solid state RFPAs. The actual waveforms are more likely to fall into general category of continuous modes. See, in conclusion, we can say that the concept of pushing and pulling data, when applied to the realism of microwave bytes, realm of dynamic interplay between fundamental data flow principles and the unique characteristics of microbial technology, we will explore how the proactive nature of the push models enables real-time data and delivers and broadcasting. Crucially for applications like live streaming and emergency alerts. Conventionally, this client-drive pull model employs on demand and data retrieves additionally for web browsing, file downloads, and remote data access. In certain properties of microwave transmission, such as line of sight requirements and sustainability to uh, atmospheric conditions, introduce specific challenges and considerations. Effectively implementation of both push and pull strategies within the, microwave networks, increasing carefully planning, reverse error correction, and adaptable bandwidth management. And autonomously understanding the of these data flow models and how they are affected by microwave technologies is crucially for optimizing data transfer in modern communication systems. As microwave technology continuously to evolve and play a virtual role in bridging connectivity gaps and partially in remote understanding areas, and deep understanding of these concepts will only become more important, whether for telecommunications, black hole, remote sensing, or rural internet access. The efficient management of microwave bytes to push and pull mechanisms remains of a cornerstone of effective wireless communications. Thank you. So these are the uh, topic is about pushing and pulling in microwaves bytes. Thank you.